So the two diagrams that represent the phase changes that occur in matter, one of them is called a phase diagram and the other is called a heating curve. Let's first look at the phase diagram. The phase diagram is defined as a graph that shows the phases of a substance as a function of temperature and pressure. So if you look at the graph that I have here, you'll see that on the y-axis, pressure is listed, and a pressure could be in atmospheres, kilopascal, torr, any of the pressure units we've learned about. And then our temperature is typically in Celsius. Now, what I'd like for you to do is we're going to put some letters on our graph, and then we're going to come back over here, and we're going to label the states of matter that are present in those specific regions. So let's first of all put an A in this section here, a B here, a C here. On the line between section A and C, let's put a D on the line. I'm going to put a circle around that. Put an E on the line here between the region A and B, and put an F representing any point on the line between B and C. Then come over to the point where all three of these lines intersect right here. And this is a specific point we're going to label. We're going to call this point G. And then up here at the very top point, this also is a specific point. We're going to call this point H. Okay. So let's come back over and label what each section, what state of matter is present in each section. So for section A, we're talking about the entire region, any temperature and pressure that would be present in this region of the graph. Any temperature, any X and Y value, temperature and pressure that you would find in this region of the graph. In that particular region, you would have the substance existing as just a pure solid. In section B, which represents the little region here, temperatures and pressures in this region, this is where the substance would be just a pure liquid. And then finally, in region C, which is representing any temperature and pressure below the graph here, okay, that would be where the substance would just be in the gas phase. Now, let's talk about the points along the lines here that I've labeled. So D, any temperature and pressure that would fall on the line here, notice it's between the solid and the vapor state. So that means you will have a solid in equilibrium with a vapor or a gas. So this is where your phase change will be taking place. And remember, we learned in class that those phase changes that occur, solid to gas and gas to solid, are called sublimation and if you're going gas to solid, deposition. Let's look at any point here along this line that I've labeled E. This would be between the regions A and B, which means you are between the solid and the liquid phases. So that's where your phase changes will be taking place depending on the direction that you're going in. You will be going from solid to liquid is called melting. And liquid to solid is freezing. F, this is where we're going to have a liquid in equilibrium with the vapor. or the gas. So we're familiar with these phase changes. Liquid to gas is called evaporation. I'll abbreviate that. And gas to liquid is condensation. All right, then we have two special points. Point G. Notice at point G, this is the point on the graph where all three lines intersect. This point has a special name. It's called the triple point. That's easy to remember because three lines come together. So therefore it's called triple point. Now the definition of this point, it is the temperature and the pressure at which you have a solid, liquid, and a gas coexisting. So they're all three present at the very same time. It's a very unique temperature and pressure. Like on this graph, you could read down and it would be equivalent to the temperature at negative 15 degrees Celsius. And if you were to read over here, it's at 6 atmospheres of pressure. There's a temperature and a pressure that corresponds to that. Finally, the point that I labeled point H, way up here at the top, this is called the critical point. The critical point is defined as the temperature and pressure past which only gases exist. So on any phase diagram, if you take a look at where the critical point is, and if you were to kind of read down to the corresponding temperature, I'm kind of freehanding this. So the critical temperature here is 200 degrees Celsius for this substance, and the critical pressure, you read it back to the pressure axis, that's what P sub C, critical pressure, is 300 atmospheres. So anything past that, only gases can exist. Okay, so that is the phase diagram. Next, we'll look at the heating curve.